Okay, as always, we're going to be doing all this from our fancy new Ubuntu virtual machine we created in Chapter 1. If you don't already have one of these, it's an Ubuntu desktop VM running on VirtualBox, and full instructions on how to make one can be found in Section 2 of the Basics chapter. The first thing we're going to do is install Terraform on the box. Let's open up a browser and search for Download Terraform, and hopefully the first hit should be the Terraform download page. Here we go. Click on the Linux 64-bit version, as we're using Ubuntu, and then save it somewhere. As you can see, it's possible to install this on Windows and Mac too, but as mentioned before, DevOps tools run primarily in the Linux space, so we're always going to be working on our Linux VM in these courses. Jump back to the terminal, browse the downloads, and we can see our file is there in a zip repo. We can use the unzip command to unzip it like so. And now if we list again, we can see the actual binary. To allow us to use it, we need to copy it to somewhere in our path, so I'm going to copy it to user bin here. Okay, great. Now we've copied it, I need to also make it executable using chmod. Right, let's have a look and see if this has worked using Terraform --version. You can see here that I've downloaded version 0.12.18. This is the version I'm going to be using right the way through this Terraform chapter, purely because it's the most up-to-date version at the time of making these videos. I would recommend that even if a newer version is available by the time you're going through this course, you still download exactly this version, because it will prevent you getting any errors that might result due to changing syntax between versions as you work through the examples we'll be going through. In this chapter, I'll be using AWS as the target for our virtual machines that we create with Terraform, so the first thing I need to do is configure my machine with the credentials to allow it to access my AWS account. AWS comes with a command line tool to do this, which we can install using pip. If you're not familiar with pip, it stands for Python Install Package, and is Python's package installer for getting hold of stuff from the Python community. It's similar to apt, and we can install it on our machine using sudo apt install python-pip like this. Once that's finished, let's get hold of the AWS command line tool using sudo pip install AWS CLI. We'll just let that run through there. Good. Now, I know that when I run this, it's going to ask me for my AWS keys. So the first thing we're going to need to do is to go into our AWS account and create them. Hopefully you've got an AWS account, but if you don't worry. You can get a detailed walkthrough of how to create one in the Basics chapter section on spinning up a virtual machine in the cloud. Let's head on over to the security credentials section here. Ignoring this warning about IAM for the moment, it's not relevant right now, and expand the section marked Access Keys. Create a new access key, click Show Access Key, and then copy the access key ID to the clipboard. It's important to say at this point that you should never ever show these details to anyone the way that I'm obviously doing right now in this video. They should be treated as highly sensitive as they allow people to spin up resources in your account. The only reason I'm exposing my root keys in this video is because I have of course deleted them immediately after doing so. Right, let's head back to the terminal and launch the AWS configuration tool with AWS configure. Now I can paste the key that I've copied in there, then go back and do the same with the secret key. And I'll put a region in of US East 1 as well, which is the default. Okay, that's it. Our computer now has access to our AWS account. The credentials for AWS live by default in a folder called .aws in the home directory in a file called credentials. If we cat that file, we can see AWS has added the credentials we gave it. You can just do this manually instead of using the configure tool. It doesn't actually make any difference. Now I'm going to make a Git repo for the work we're going to do in this chapter. In this case, I've already got a folder called repos, and if you want to follow the course exactly, then you might want to use the same naming convention, or browse to wherever you normally like to keep your repositories, either's good. I've got this leftover Nginx repo from the previous chapter, so let's get rid of that to be nice and neat. To create a repo, we'll need to open a browser and browse to github.com again, which is the Git provider I'll be using for all these courses. If you don't have a GitHub account, I'll cover how to create one in the basics section on using Git, so it could be worth popping there now again. OK, let's navigate to the repositories and create a new repository for our Terraform work, which I'm going to call Terraform. I'll give it a quick description here. You can make it public or private, but I'm going to leave mine public on this occasion, as all the code I create during these courses is going to be freely available for you to clone should you want to get hold of it to copy and paste anything. As we don't have any code to go in here yet, I'll initialize it with a README and then create. Now we can select the clone or download button. In the Git example in the previous chapter, I used the HTTPS clone links, which causes Git to request a username and password each time you do anything that requires authentication. Because at that time I wanted to keep things simple, I didn't go through the process for SSH key creation, but I'm going to do that now, as it'll make things much quicker for the rest of the courses. With that in mind, click here on Use SSH, and when prompted, choose the link that says Add a new public key. You can also get to this from the main menu up in the top right. Give the key a title, and now let's switch back to the terminal and type the command SSH keygen. We can accept all the defaults here, and it will create us an authentication key in the correct place with the correct permissions. We're going to need the public key to put in Git so that it recognises us. So type cat home.sh/id_rsa.pub, then copy and paste the key it shows us into GitHub like this. There we go. Now you can see it's saved the key. So now, if we head back to the repo, we can copy the SSH clone link into the clipboard and use it to clone the repo without needing a password. I should say at this point that the SSH link is always the one that begins git at. If you've got something that begins HTTPS, then it's the HTTPS link and will require a username and password. I quite frequently get these confused when I'm copying and pasting them from the site, so I thought it worth mentioning. Great, it's cloned it. Let's quickly check inside, and yes, we can see there that it only contains the readme.md we asked to be created. As we've got past the basics section, we're going to be behaving like full DevOps professionals at all times. So let's open up Visual Studio Code here and open the folder of the repo we've just downloaded. There will be a few Linux purists amongst us, I'm sure, jumping up and down saying that Vim is just as good as a full editor and you never need anything but the terminal to work in and all that jazz. But if you want an in-depth look at how to install VS Code and all the benefits that I think you get by working with it, check out the section in the basics chapter that covers editors. It's well worth a look. Anyway, let's open our Terraform folder here, which you can see is in Home Repos, and take a look. So far, again, there's only one file, so we're going to create a new file called main.tf. .tf is the file extension for Terraform files, and because I've installed the Terraform extension on my editor, it will do proper syntax highlighting of those files. Now, I'm going to cheat a bit and dump some copy and pasted code in from the Terraform docs that I copied earlier. Don't worry about the details of what's in this, as I'll be going through every single detail of this in depth, step by step throughout this chapter. For now, I'm just going to quickly demo what Terraform actually does, and you don't need to remember all of this code. All this code will be available at Lernard on GitHub as well, if you want to clone it from there to play with. Right, I'm going to quickly remove the default region here, because I want to highlight the fact it exists when I run Terraform for you, as you'll see in a minute. As we're using quite a new version, I'm also going to quickly change to the newest syntax here. And now we're good to go. You might remember in the introduction that I said that Terraform works like a Christmas list. Well, that main.tf file is our Christmas list. It's just a list of what I want Terraform to make. There's no flow logic or if statements or anything like that that you might get in normal code such as Python. It's just a list of what I want, and now I'm going to send it to AWS using Terraform. First, I need to initialize the directory, which downloads some plugins for me to communicate with AWS. Don't worry about remembering the details of these commands here, as we're going to come back to all of this in detail again. Now the directory is initialized, I'm going to run a plan, which is just like a dry run that tells me what would happen if I ran it for real, but won't actually run anything. You can see here, because I removed the location, it's asking me to specify it, which I wanted to draw attention to, and I'm choosing US East 1 because that is the default region, labelled North Virginia in AWS. If you ever find that you think you've spun something up in AWS, but you just can't seem to find it in the console, chances are you might have spun it up in the wrong region. Now the plan is done, and here you can see at the bottom it's saying 1 to add, 0 to change, 0 to destroy. This is really the line to concentrate on in any plan. The above details tell you exactly what it's going to make, but often the key thing you'll want to know when working on a job is, does it look like it's making about the right amount of stuff? It's actually quite possible with Terraform to accidentally destroy an entire web estate of a business in one command. So when you look at that line, if you see 1 to create, 300 to destroy, you can be sure you don't want to run it. That line is your safety net. In this case, 1 to apply and nothing to destroy looks about right, so we know we're good to go. Now we can use Terraform apply, which will do the same thing as plan, but for real this time, in the actual cloud. Okay, before I kick this off, let's go to the AWS console and take a look at what we've got there. So, browse to the console. Here we go. And as I mentioned before, you can see here which region we're currently in. As I chose US East 1 in Terraform, I must choose North Virginia in this list to see what it is I'm going to create. Let's go to the EC2 console here, and you can see it's currently saying I have no running instances. If we click through and go and take a look, you can confirm that yes, that is the case. At the moment, there's nothing in here. Righto, let's kick this off. It might take a few moments. We're going to have to wait here to actually spin up a real machine. Okay, success. If we now look back in the cloud and click refresh, we can see that a virtual machine has indeed spun up in our account, with the name Hello World like we chose, and the size T2 micro because it's cheap or possibly even free. Let's jump back into the code, and I'm going to add the region back in now so we don't have to keep typing it. I'm going to cover in detail what each of these stanzas of code are, but it's this bit at the bottom section here that's saying, please give us our one AWS instance. In the previous section, the introduction, you might remember I made an animation of what idempotency was with glasses of water. I'm going to illustrate this same principle now with Terraform. When we ran our code, it made us one virtual machine. If I now run this same code again, will I get a second one? No, I don't get a second one. See here, it has done nothing. 0 added, 0 changed, and 0 destroyed. That is because Terraform is idempotent. It isn't saying, spin us up a virtual machine. It's saying, spin up one and only one virtual machine. If there is 2, make it so there is 1. If there is 1, keep it at 1. If there is 1,000,000 machines, get rid of all but 1. It's declaring the state that will be the same each time regardless of starting position. At this point you might be yelling, but how then do I get my second machine? To do that, we just add a count value here with the amount of machines that we want. Now, if we perform the same apply, Terraform declares there is 1 to add, because it's looking at the situation, seeing that there is an existing one, that we need 2, and then adding 1 more. Let's see what happens. Yes, sure enough, it's created one more virtual machine. And if we were to run this again, then it would make no changes, as there would then already be 2 machines running. So the Terraform files are a complete description of what will be in AWS after a run. I should point out that anything created manually outside of Terraform isn't affected by Terraform runs, whether we're applying or destroying, and we'll go into why later in this chapter. Okay, I think we're about done for this first section, this demo. As I don't want to actually start paying for the resources I've spun up, the last command I want to run is terraform destroy, which removes everything previously created. You can see here it says to destroyed, and I'm going to go and double check that in AWS. And yes, you can see here they've been terminated and are no longer billing or costing me money. Finally, throughout these courses, I want to be constantly practicing the skills that will get us that big money DevOps contract. So we're going to behave as if we're always in a professional environment. With that in mind, I need to push my changes back to the Git repo we've made. Don't worry if you didn't make any changes yet, as this wasn't a follow-along lesson, but I'm going to do it anyway. You'll have loads of changes in the following sections, so it's worth creating a repo for those in any case. Alright, let's do a git status here. You can see here there's some files we didn't create that have been picked up by Git. These are supporting files created automatically by Terraform, and we don't want to accidentally push them to our Git repo. To prevent these files being picked up by Git, we need to create a gitignore file. This file is just a list of things that Git knows are not supposed to be part of the repository, even though they exist in the same folder. Luckily for us, Terraform has a pre-made one of these for Terraform files. Here it is. So I can just copy and paste that into a file named .gitignore now. Don't forget the dot on the front of this name, by the way. There we go. Write and quit. Now, if I do a new git status, you can see that it's only detecting the files I want it to, my main.tf and my newly created gitignore. As there's going to be a lot more stuff going into this repository over the course of the chapter, I'm going to tidy this up a bit by creating a folder named section2, as that's the one we're in right now, and I'll quickly move the main.tf file in there. Now I'm ready to add the files with git add, and commit my changes with a sensible message, then push them back to GitHub. Okay, we've come to the end of the demonstration section. In the next section, we're going to do our own example, going line by line through each thing required to spin up a basic virtual machine in the cloud. Hopefully see you there.